we have another optimization problem, and this one doesn't look like that intimidating compared to number 1. So this one looks more intimidating, not other than intimidating. So we're going to look at this problem that looks scary, which involves some expected values. So first, x1, x sub 1, x sub 2, blah, 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 x sub 10, no, x sub 100 are sorted. Well, kind of like sorted, right? And we have the absolute value sum equal to 1, and the sum is equal to 0. And among all such 100 tuples of numbers, the greatest value that x to sub 76 minus x sub 16 can achieve is m over n, where m and n are relatively prime positive integers. Find m plus n. Very interesting. So now let's look at how is this even characterized? Like how can you even use this piece of information? So let's first list. So now we can just make their sum to be always equal to 1. No, their sum to be always equal to 0. Now, since they're actually in the increased order, for this problem we want to maximize x sub 76 and minimize x sub 16. And the best case would be what? Would be when all of these are equal and all of these are also equal for that to actually happen. Right? Because let's say if this one is like m sub 1, then in order for this to be minimized, then this one should also be m sub 1. So if they're all equal, then what? Then actually, well, if we exist number between this interval, then what's going to happen? Then we were going to push this even back. And we actually don't want that. So therefore, any number between x sub 17 and x sub 75 inclusive are all zeros. And all numbers between x sub 1 and x sub 16 are all negative numbers. And x sub 76 to x sub 100 are all positive numbers. And that is how we're going to minimize this difference. And indeed, all of these numbers are equal, and all of these numbers are equal. So now, we can just set this to be x. So basically, we actually have 16x plus, actually let me just try to be clear here. Plus this is equal to a 0. And minus is equal to 1. Now we just add the two equations up. So this one we can evaluate as 25. So this just simply gives us, well, let's call this number 1 and number 2. Then number 1 plus number 2 just gives us 50x sub 76 is equal to 1. So x sub 76 is equal to 1 over 50. Bro, my writing is terrible. To 1 over 50. Now, after we find that, then x sub 16, we can find it to be 1 over 16 times 1 over x sub 16 is equal to 50 times 25, 1/2. Yeah. So now we're going to subtract this. So x sub 76 minus x sub 16, it's just equal to 1 over 50 minus negative 1 over 32, which is equal to 1 over 2 times 1 over 25 plus 1 over 16, 800 over 41. So by the typical Aime Ii answer extraction, we're going to get 841 as our final answer. Thank you for watching. I hope you enjoy, and I will see you in the solution of problem 7.